Welcome, geometry students, to section 10.4, perimeters and areas of similar figures. To get you understanding the concept of similar figures, we're going to first take you to an example, real-world example of a problem I had to solve when I was a kid. When I was a kid, we had a backyard pool, and my dad wanted to expand it. So let's just say, for simplicity's sake, the original dimensions were 4 meters by 2 meters. And let's say, just out of simplicity, he wanted to make it bigger, but I don't remember the exact scale factor. But let's say he wanted to make it 3 times bigger. What would the new dimensions of the rectangular pool be? Well, it would be 12 meters by 6 meters. Okay, now, why is this important? Well, in order to construct the new pool, we had to have the fencing around the pool. So that relates to perimeter. So how would the perimeter change with the new pool? Well, first we need to figure out the original perimeter. So the original perimeter would be 4 plus 4 plus 2 plus 2, which is 12 meters. Okay, now what would the new pool be? Well, we need to put 12 meters here, match on this side, 6 meters over here. The perimeter would be 12 plus 12 plus 6 plus 6, which equals 36 meters. So remember, we used this times 3 earlier. Let's make it a little bit different. Let's make it orange. Is that the same scale factor that the perimeter undergoes? Yes. The perimeter is 3 times bigger in the new pool than it was in the original. Okay. In addition to fencing in the new pool, we also had to get a new tarp. So the tarp is something that you use to cover the pool, and it covers the entire area of the pool surface because you need to keep the bugs out and keep the pool warm at night. So how does the area change? Well, let's figure that one out. So the area, first we need to know that the area of a rectangle equals the length times the width. So the area of the original smaller rectangle would be 4 times 2, or 8 meters squared. What about the new pool? Well, 12 times 6 for the area, which equals 72 meters squared. Is this the same thing? Is this times 3 for the area? You'll notice that it is not. What is this difference? What do you multiply 8 by to get to 72? You'll notice that it is times 9. Why does this happen? Well, because we're multiplying dimensions and it compounds the scale factor. So if we're talking about similar figures, if the scale factor of two similar figures is A to B, okay, so in this case, it was 3 to 1 or 1 to 3. The smaller figure was a 1 to 3 ratio with the scale factor, okay, and we're talking about the length there. So scale factor 1 to 3. Then the ratio of the perimeters is the same, okay? We already determined that. The perimeters will stay the same. If it's a scale factor of 3, the perimeters stay the same, so it's still going to be A to B, 1 to 3. The ratio of the area, though, what did it become? It didn't become just 3, it became 9. So it becomes A squared over B squared. So 1 squared over 3 squared is 1 over 9. So see how the scale factor changed when we used the area. Okay, and this basic principle is what guides this entire section. Let's go ahead and move to example 1. We're given similar trapezoids here, and we're asked to find the ratio of the perimeters first. Well, first we have a problem. We notice that we have some missing values. So if this is 12 and this is 6, we need to find the other missing values. So obviously this is a scale factor of what? This is a scale factor of 2 to 1. So the smaller trapezoid, mislabeled as KITE, clearly not a kite, is 3. It's half the size. I mean, this is 9 over 2, and making this 15 over 2. Okay, let's use decimals just for simplicity's sake. We have a calculator handy, and we're going to go ahead and use that. So this is 7.5. Okay. Now, what is the ratio of the perimeters? Well, for the perimeters, we need to add up all the sides. So we're going to do, first we're going to add up all the sides for trap. So we're going to do 12 plus 6 plus 9 plus 15, and that equals 42. So the perimeter for trap is 42, so we're going to go ahead and write 42, divided by KITE, 4.5 plus 7.5 plus 3 plus 6, and that gives us 21. So we're going to write that in green, 21. You'll notice that it stayed the same. It's still a 2-to-1 ratio. What do we expect to happen with the ratio of the area? Well, let's go ahead and calculate the area. For a trapezoid, the area equals, let me write this in blue, area equals 1/2 the two bases add together, B1 plus B2 times the height. Okay, so what we're going to do is we're going to do that for the big triangle first up here. So area equals, we're going to do 15 plus 12 times 6 divided by 2. The height needs to be perpendicular to the base, so the area equals 81. So we're going to write 81, let's write it in purple, stay consistent, 81. 2, let's find the area of the other trapezoid now. So the area equals the two bases added together, 7.5 plus 6 times 3 divided by 2. What do we get? We get 20.25. Let me write that in green, stay consistent, 20.25. How do these two relate to each other? Well, let's do 81 divided by 20.25. What do we get? We get 4-to-1. That's exactly what we expected to happen based on the principles we learned above, okay? So the new ratio is 4-to-1, and you'll see that's 2 squared over 1 squared. That's the same thing. Let's move on to example 2. The ratio of the areas of two similar squares is 1-to-4. Now, notice how we're talking about areas first. So we're talking about area 1-to-4. Keep in mind, that's the same thing up here. The ratio of areas is the same as a squared over b squared. So let's do that. Let's call this a squared, and let's call this b squared. What is the ratio of their perimeters? Well, if we're looking for the ratio of perimeters, we know that it's a ratio of a to b. So how do we go from a squared to a? Well, what we do is, to undo the squared, we take the square root. So what we're going to do is we're going to take the square root, not just of a squared and b squared, but we're going to take the square root of 1 and 4. So we're going to take the square root of 1 over the square root of 4, and that's going to be equal to a over b. Well, we simplify that. Square root of 1 is 1, square root of 4 is 2. So the ratio of the perimeters should be 1-to-2. Okay? Now let's use this information. If the area of the larger square is 50 units squared, what is the side length of the smaller square? So what we need to do here is we need to set up a little ratio. Okay, so what we do is, let's say, we already know that the areas are 1-to-4. And we say, we're setting up a ratio, proportion, that the bigger one, the larger square, is 50 units squared. And we want to find the area of the smaller one. Okay, so we're going to put that as x. What we're going to do is we're going to cross multiply and divide. So we get 4x equals 50, divide by 4, and we get x equals 12.5. Okay, that's our area of the smaller one. Now, how do we find the side length of, the smaller square? Well, we know the perimeter is going to be the square root of that. Okay, at least in terms of its ratio. So this is, we know that the area is 12.5, and we know the ratio is 1-to-4, but in this case, we don't exactly need to know the ratio of the perimeter because we want to know the length of a side. Okay, so in this case, we just need, this is kind of a tricky problem, we just need to know the formula for finding the area of a square. So we know the area of a square, based on the previous sections, is side squared. Okay, side times side, because the sides are identical, side times side is side squared. And we know that the area of the smaller square is 12.5 s squared. So now what we do to get the s by itself, we just take the square root of both sides, and we get s equals 3.54 rounded, and that is units, because we're no longer dealing with square units. Hope this was illuminating to help you guys understand similarity, and we'll see you next time when we talk about trigonometry and area.